Alrighty, good morning, guys. We're going to start off with the forms of energy questions, so go ahead and find those for me. So I've got the questions up here, and then we'll go over the answers, so make sure that if you get something wrong, go ahead and change it because I will give you credit for making changes to your answer sheets. So, all right, we'll just kind of go down 1 through 7. Number 1, energy that travels like a wave uses vibrational motion but needs a medium in order to travel. That's sound. So sound needs either air to travel through, or it needs some sort of solid, so like a wall, water, some sort of liquid. Sound can travel through water, but it needs something there. It can't just travel through empty space. So, number 2, so that would have been letter F. Number 2, energy that is released when the nucleus of an atom is split or two nuclei are fused together. So that's going to release a lot of energy, and that would be nuclear energy. Letter D. This is the same kind of energy that nuclear power plants use, that they're trying to produce. Bad thing with that is that it always makes a byproduct, which is radioactive. So that's the problem. Where do you store that radioactive waste? Number 3, energy that is released when the bond between two molecules is broken. That would be chemical energy, A. This is the kind of energy that's stored in your food. So when your body breaks apart those molecules, it's going to release energy that you can use to do all sorts of things. Number 4, energy that has an object has due to its placement on Earth. There are 2 types of this, kinetic and potential, which I know we've talked about, and that would be mechanical energy, letter C. Remember, kinetic energy is the energy that you're using to move, and that's what mechanical energy is, movement. Okay, and then the potential energy is the stored up energy. So I know we talked about that in our last unit with weather. Number 5, energy that is in the form of heat. That's thermal energy, letter G. Number 6, energy that travels like a wave. It uses vibrational motion. It includes light, but it doesn't need a medium in order to travel. So it doesn't need air. It can travel through empty space, and that would be E, solar energy, or light energy. So that's why, oh, sorry, those are our dogs. So that would be, that's why we refer to anything with the sun, solar. Number 7, energy that occurs when electrons flow from one place to another. That would be the last one, which is B, electrical energy. So you're moving electrons from the power source with battery through a circuit, and that movement of those electrons is what powers your lights to turn on. So there are more types of energy, but these are some of the big ones. So everything can be converted in between these energies. So the chemical energy, for example, the chemical energy that you've eaten that gets released when your body breaks down food can then be transferred and transformed into mechanical energy, which allows you to move. Okay, so we can always change these forms of energy. They're going to be changed back and forth. So the next thing we're going to move on to is energy and energy transformation questions. So you want to try to find those. So the first part is you need to define, those terms right there: energy, work, newtons, and joule. Energy is the ability to do work. Work is going to occur when a force, so a push or a pull, is applied to matter, and then that matter is going to move. So you need energy to be able to use a force to, the force doesn't just magically come out. You've got to have energy that's going to cause that force to occur. When we were doing those activities with Newton's first law, you had energy stored up in your finger to flick that washer, and then the washer then hit that big stack of washers to cause movement to occur. So the energy, some of you wrote that down in your answers, that the energy was transferred from our finger or that moving washer into the stack of non-moving washers. So the energy just got transferred. So you need that to be able to do work or to cause the movement. Newtons, this is the unit that we use to measure force, but it also measures energy and work. And then the joule is an exact measurement of energy. We can convert these into kilocalories, which would be very similar to the calories that you see on your food labels, so your nutritional labels on your food, because that's basically what a calorie is: how much potential energy is stored up in this food. So there are some foods that have a lot of stored up energy. Now the problem is, if you consume too much of this, you're not going to use all of that energy, so it gets stored in your body as fat. So, okay. The next thing you had to do was you had to read that paragraph, and it was under, let me find it. Okay, so it was about you running down the street and your feet are hitting the pavement, and it's kind of talking about all the different types of energy transfer that are occurring. And so what you had to do was describe 3 energy transformations that occur when a car burns gasoline. So one of them, because I didn't want you, because they gave you the example, so then you had to apply this. So one way would have been moving the gasoline. So you could have done mechanical energy to mechanical energy. So you've got stored up energy in that gasoline, and that's going to transition into or get changed into the car moving. And then you could have also had mechanical into thermal. So as your engine is working, it's going to create heat, or that mechanical energy is going to be converted, I guess would be the better word, converted into heat energy or thermal energy. So you could have said that. You could have also done mechanical energy into electrical energy, in that all of the movements, or I guess you could have said maybe no, it would have been mechanical, from the gasoline powering your battery. So your battery then would be converting that into electrical energy to power your console in the front of your car, or to do any of the other functions in your car, rolling down a window if you have automatic windows. You could also argue that you could have mechanical energy into sound energy. So, your motor running would then be converted into sound energy so you can hear the motor running. You could argue mechanical into, you could argue it into solar, although it'd probably be better to do mechanical into electrical, which would then become solar for your headlights. So your battery powering, becoming the electrical energy to power your lights, which would then be converted into light energy. So there's a whole bunch of different things that you can use, or different examples for that. So if you have any questions, circle one that you came up with if I didn't mention it. Put a little question mark. But just make sure you've got 3 that I've gone over because I'll be looking at that one. And then number 3, in your own words, what does the law of conservation of energy mean? It just means that you can't create energy, nor can you destroy energy. The only thing you can do is to convert energy from one form to the other. Next year, we'll talk about the law of conservation of matter, which is basically the same thing, except it's going to say that we can't create or destroy matter. Okay, we can only change it or convert it. So this one just means you can't create or destroy energy. Alrighty, we're going to move on to thermal energy and heat. So we've got the second paragraph talking about the 2 billiard balls. If you've ever played pool, that's what a billiard ball is. You hit the cue ball, and that's going to hit either your solid ball or your stripes ball, depending on which one you are. And so what happens to the kinetic energy as one billiard ball hits the other? So the kinetic energy is going to be transferred from the moving ball into the stationary ball. This should seem really familiar because it's essentially describing Newton's first law of motion. The object at rest is going to stay at rest until the other object causes it to move. And in so doing, it's also going to transfer energy. So that moving billiard ball is going to cause the stationary ball to move by transferring its kinetic energy into the moving one, or into the stationary one, sorry. Number 2, how does kinetic energy travel when moving between 2 objects? It's going to move from the more energetic object to the less energetic object, or the one that's moving the most to the one that's moving the least. And then number 3, the 3 ways that thermal energy can be transferred, which should be familiar because we just went over this with the popcorn lab. So this should kind of be a refresher here. The 3 ways are conduction, convection, and radiation. So you had to explain using a burning candle, illustrating how the thermal energy gets transferred. So there's a couple of ways. You can have radiation occurring. So the actual fire that's coming off of, or the flame that's coming off of that wick is going to, so that light energy is going to become thermal energy or heat. And so that would be, then you would be transferring your thermal energy through radiation. Because you don't actually touch the flame, you're going to get warm by the heat that the flame is giving off. So the flame, the light energy, gets converted into that thermal energy, and then you are going to get warm off of that thermal energy through radiation by not directly touching the flame, because touching the flame would be bad. Another way is conduction. He doesn't really, it's not really going to use convection. So if you did talk about convection and you think you really have it, circle it. but you might write down both of these. So circle it and then write me a little note, and I'll look at your answer. So convection or conduction, excuse me, would be the other way that thermal energy flows, the heat flows. Because the heat is going to flow from the fire to the wax. So the wax, excuse me, is going to be touching the wick, which will be touching the wax, which will cause the wax to melt. So the wax, in a way, is in direct contact with that heat source through the wick to the flame. Which, like I said, it's not really using convection, or the circulation of air. So, alrighty, conductors and insulators. I know we talked briefly about those also with your popcorn lab, but I think you guys had this one pretty well, so that's why we didn't spend a whole bunch of time on it. Review what conductors and insulators are in the first paragraph. You need to name another insulator that depends on trapping air. So the major thing would be a coat. You could have also said maybe like a sweater or a hat, something like that, because it's going to trap the air between the clothes and your body. So something like that. Number 2, light is a form of electromagnetic radiation. It's got electric energy, some magnetic energy as well. Certain materials reflect light, which means that you're going to stay cool because you're not going to absorb the light. You're going to reflect it and send it away. And certain materials are going to absorb light. And so because they're absorbing the light, they're holding on to it, and then they're going to heat up, because light and thermal energy are basically come hand in hand. If you have light energy, you're going to have heat. You just think about your light bulbs. They get hot. It's because light and heat kind of go together. So considering this, which material will insulate your soda better in the sun? A layer of aluminum foil or a dark t-shirt, and why? Hopefully you picked the aluminum foil because it's going to reflect the light. The dark t-shirt is going to absorb it and then warm it up faster. Now, will your soda still heat up even with the aluminum foil? Yes, because of the transfer of the energy around it. Heat's always going to find a way to come in. It's just going to slow it down. Because if you remember, heat's always going to want to go from the hot to the cool. So it's always going to move that way. So the aluminum foil is going to do a better job of reflecting, therefore keeping it cooler. Number 3, read about how insulators work in regards to conducting electrical energy. If you cut a wire and joined the two ends with a piece of paper, would the paper continue to conduct the charge? And why? And the answer would be no, because the paper is not a conductor. It's an insulator. It cannot conduct electricity. Electricity will not pass through paper. It's got to be a metal, or it's got to be water. Water is a great conductor. But paper, not so much. Plastic, no. Styrofoam, no. All of those things will block the flow of energy. Which is why, if you've ever seen the electrical wirings, that's why all the wires are coated with plastic. Same thing with your appliances, or like curling irons or coffee pots or anything. The wires that are going to conduct the electricity are covered in those plastic coats to help insulate that electricity, so that when you try to go unplug it, you won't get shocked. So you want to block that conduction. Number 4, what would happen if you join two ends of the wire with a paper clip, metal paper clip, and why? And it's the same thing. You would get the flow of energy, so the charge would continue because the metal paper clip is a conductor. Electrical energy. So the next one is the electrical energy and like and unlike charges. So this one, I know in the past is been a little confusing because the like and unlike charges. Like meaning two positives, unlike, our dogs like to bark. Like and unlike charges. So your unlike charges are going to be like a positive and a negative. And then the like charges are going to be like two positives together or two negatives together. So, number one, you're giving an example of a like charge using the battery, and then you're giving an example of an unlike charge. So I just kind of gave you that example right there. A like charge would be if you had both positive ends of the battery facing together. So no, because they're like charges, there's going to be no electricity flowing between the two. If you have unlike charges with the battery, you're going to have a positive end touching the negative end, and that's how you're going to get conduction of your electricity. So, or you could have with the like, the two negative ends together. So, and that's just the way things work. So you've got to have the unlike charges in order to get the electricity to flow. Number two, reading about how electrical energy is moved in the electrical energy. Why will electricity flow only in a closed circuit and not an open circuit? With the closed circuit, you are completing the circuit. There's not a hole. It's like trying to pass water through a tube that has a hole in it that's in two pieces. You know, you need to have it connected in order to get the water to flow completely. It's the same exact concept with your electricity. You've got to have a closed path, otherwise your electricity is not going to flow. So that's what your light switches are responsible for doing in your house. When they're in an on position, you have a closed circuit. The electricity is allowed to flow, which is why your lights turn on. When you turn your light switch off, it's like cutting I don't want to say a hole, but cutting your hose and separating them. Your water's not going to flow through that hose anymore because there's a hole now. Except unlike if you cut a hose and it's kind of undoable unless you try to tape it back together, your light switch is meant to, it's almost like a gate opening and shutting. So, number three, kinetic energy is mechanical energy that is being used currently. Potential energy is the possible energy that an object has that could be converted into kinetic energy. So is the energy that's stored in a battery potential or kinetic? That would be potential because you're not using it. Because the key word there is storing. Now, can it be converted into kinetic? Yes. But that is the energy that's stored in the battery. Stored, keyword, potential. The energy that's being used in the battery, kinetic. And your last little bit, this is kind of putting everything together. We've got Susan walking from her front door to her car. She drove to the house of her friend Carlos. When she gets out of the car, she notices that the hood of her car was warm from the heat of the engine. So you need to find one energy transformation in the passage that performed work. So what made that required a push or a pull. So her walking required a push or a pull. She had to push off of the ground. So in order to do that, she would have needed to take that energy that she'd eaten, the chemical energy that was stored in her food, and she needed to convert that into mechanical energy. Any other description of her moving at all, getting in and out of the car? So any sort of movement, she's taking that chemical energy from her food, converting it into mechanical energy of the movement. Number two, describing one energy transformation in the passage that could be performing no work. The gas heating your engine doesn't require a push or a pull yet. Now, once you make the car start going, that would be considered an energy transformation that's performing work because the car is pushing or pulling in order to, it's causing movement. But the actual using of the gas to start the, to heat up the engine isn't actually requiring any movement. Now, to get the car to go, there's going to be movement within the engine itself, but from the gas to the engine, there's no actual work done there. And then number 3, you needed to explain how the law of conservation of energy could be applied to the situation. So the energy that the gas from the car, so the gas that the car is going to use gets transferred from being chemical energy, it's kind of like the food for the car, into mechanical energy. So the gas that she has doesn't just disappear, even though you use the gasoline and the gasoline in the gas tank goes down. So it appears at first glance that you're using up this energy and it's going away. But what's happening is that gasoline is being transferred into a different form of energy. So the energy isn't going away. It's just the gas that was stored in the energy then gets converted into another type of energy. So some of this was kind of review. Some of it was a little new. I'll be online. I'll be online later if you need anything. So, because I think today is Friday. I'm filming this really, really early. So I think you guys are going over this on Friday. So, I will be on Sunday if you have any questions. Just make sure you give these sheets to the sub, and any questions that you have, you can email me, or you can email me and we can do a Google Hangout on Sunday, or you can just come in Monday morning and ask. So I believe next up you have, I think you might have a Socrative, I think is what's next. So to kind of wrap everything up. So hope you have a good weekend, and I'll see you Monday.